Hello, welcome back. In this segment, I will show you one interesting application of extended Euclidean algorithm to prove a basic theorem. Let's say we have three numbers a, b, c such that c divides both a and b. Then we are claiming c will also divide the greatest common divisor of a and b. If you play with a few numbers a, b, c, you can convince yourself this is true. But we will prove it for more general case, of course. Let's take an example. Say A to be 12, B to be 30. We know GCD of A and B. Let's call the GCD to be D. Yeah. What is GCD of A and B in this case? We have seen GCD algorithm. For this case, we can do it manually. The greatest number that divides both 12 and 30 is 6. The theorem is saying if you are able to find a C which divides A and B, let's say C to be, for example, C to be 2 or 4. 4 cannot be the answer, right? 4 doesn't divide 30. C can be 3, for example. 3 divides 12, 3 divides 30. We are saying 3 divides 6, which is true. That's what we need to prove. That we need to prove C divides D. We can also try other C's, right? For example, C to be 2. Yeah, we can see clearly 2 divides 6. So how do we prove this? It turned out we can easily use the extended Euclidean algorithm to prove this. So the proof is as follows. Let me prove this for a general case, right? This is the premise. C divides A and C divides B. This implies that C divides any linear combination of A and B. So when I say linear combination, it means any AX plus BY form. We proved this earlier in one of the integer divisions video segments. If C divides A and C divides B, we can conclude that C will divide any linear combination of A and B, AX plus BY. Yeah. We also know that if you have GCD of two numbers A and B to be D, D can be written as A times X plus B times Y, meaning given A, B, and D, we can find X and Y using extended Euclidean algorithm. So this we know for sure from extended Euclidean algorithm. Given D, there exists X and Y such that D is equal to A times X plus B times Y. Okay, we already proved the fact that C divides any linear combination of AX plus BY. Okay, we can now replace AX plus BY by D. This means C divides D. So what we have proved is that if you know a number C which divides A and B, that number C will also divide the greatest common divisor of A and B. And the proof comes straight from the extended Euclidean algorithm. Extended Euclidean algorithm is saying that given D, given A and B, it can help us to find X and Y such that D is equal to A times X plus B times Y. We do know that from integer division properties that if C divides A and C divides B, C will divide A times X plus B times Y. This we have already proved in the integer division segment, which means C divides D because A times X plus B times Y is nothing but D. Okay, so we have achieved the conclusion that C divides D, which is the GCD of A and B.